People, I'm Mike, and in this video we're gonna talk about powers of numbers or indices. It's gonna be a very comprehensive lesson, a very comprehensive tutorial. I'm gonna take you through everything that you need to know about powers of numbers or indices, absolutely everything that you need to know. Okay, so if you're here for that, then let's begin. All right, so we're talking about powers of numbers. Okay, yes, a number can be written repeatedly like this. You can have 2 times 2 times 2 times 2 times 2. All right, so to save yourself the stress of writing the same number repeatedly, we can just simplify everything by writing it in an index form. Okay, so this one, we're going to count the number of 2's that we have here. We have 1, 2, 3, 4, 5. So 5 of the 2's. Okay, so this one can be written like this: 2 exponent 5. So this numbers have been written in the index form. Okay, now we can have something like this too. We can have 3 times 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 3 till we get tired. Okay, now to save yourself the stress, you want to save the page. You don't want to waste the page. Okay, so with this one, we can write it in an index form. We count the number of 3's. That's 1, 2, 3, 4, 5, 6, 7, 8. All right, so that is 3 exponent 8. You're there, right? So we can write numbers in index form. Now, before we start, I would like to take you to the first and the very most important thing. I mean, if you're now beginning with indices or powers of numbers, there are 1 or 2 things that you have to know. Okay, and that is the laws and the rules. Very important. So indices is actually characterized or governed by set of laws and regulations that you're going to use to solve questions pertaining to this topic. All right, so I am going to take you through the laws for the first time. You're going to need it, so we're going to do that. All right, great. So now let's go to the laws of indices. So with the laws, the first law, that is the multiplication and addition law. Let's have a look at that. Now you can ask something like this. Okay, maybe you have a exponent 3 times a exponent 2. All right, so with the first law, that's a multiplication law. If you have a exponent 3 times a exponent 2, now a exponent 3 can be written as this: a times a times a, right? Okay, then we have times a exponent 2, which is a times a. Okay, so now let's do it. How many a's? Let's put them together. We have 1, 2, 3, 4, 5 a's. 5 a's, so that is going to give us a exponent 5. Do you get it? Okay, so that is it. In actual sense, if you have something like this, there's going to be the answer. Or if you have a exponent 4 times a exponent 1, this is the same as a times a times a times a times a. Okay, that is a exponent what? A exponent 9. All right, brilliant. Oops. A exponent 5. A exponent 5. Okay, right. So now, looking at this one, we can deduce a law from this. Can't you see that here we had 3 a's, here was 2 a's, and the answer, when we counted them or when we multiplied them, we got 5 a's, or a exponent 5. That means we can deduce a law from this rule. And that is the first law of indices. The law says that if you have, let's say, a exponent m times a exponent n, it is going to be a exponent m plus n. Do you get it? So a raised to the power any number multiplied by a raised to the power any number is going to be a raised to the power sum of the exponents. All right, so a index any number multiplied by a index any number is going to be a exponent the sum of their exponents. Okay, right, so let's take some examples. Example 1, 2 exponent 3 times 2 exponent 4. So by the first law, we have 2 exponent 3 times 2 exponent 4. That is going to be 2 exponent 3 plus 4, which is 2 exponent 7. All right, 2 exponent 7. Then we move forward. Another example. Let's say 3 exponent 2 times 3 exponent 5. Okay, that is also going to be equal to 3 exponent 2 plus what? 5. All right, which is 3 exponent 7. Why am I getting 777? Okay, yeah, we can take more examples under this rule, right? So let's see. 2x exponent 4, y exponent minus 3. Then here 4x exponent minus 2 and y exponent 6. All right, so now we have to solve this one. This is our third example. We have to solve this. Now this is what you have to do. You multiply the numbers, okay, as well as the letters. So 2 times 4, that is 8, okay. Then x exponent 4 times x exponent 2. So that is like this. Let me put it here. x4, okay, times x negative 2. All right. Then we have y negative 3 times y6. The naught is also representing times, okay. So now, as the same base, they are multiplying according to the law. You add the exponent. So here we have 8, 4 plus minus 2 will give us x exponent 2, right? Then y minus 3 plus 6 will be 3. So the answer is 8x exponent 2 y exponent 3. That is the answer for the first law. Okay, now I hope you understand. Whenever they have the same base, you just, and they are multiplying, you add the exponents. Okay, brilliant. Let's go to the second law. So the second law of indices. The second law. Now this is the second law. In case you have a exponent 5 over a exponent 4, okay, that's it. You have to divide. So a exponent 5 divided by a exponent 4. We can write this one as this: a times a times a times a times a divided by a times a times a times a. All right, now after we can cancel them out. So a cancels a, cancels a, cancels a, cancels a. So the answer is a. Okay, when you do it this way, you have it. All right, so from this we can deduce the second law. That goes like this: that if you have a exponent m, okay, divided by a exponent n, then the answer is a exponent m minus n. Hope you agree. So from here, all right, you just take 4 from the 5 and you get 1, okay, and a raised to the power 1 is still A. That's why I left it as A then. So here, the second law actually is the division or the subtraction law, that if a number, all right, is divided by, that the same base, okay, what you have to do is to subtract the exponents. All right, so this is a quotient law. Okay, yeah. So now let's take some examples related to this. Now we know the law. The law says if you have a exponent m divided by a exponent n, then you have a m minus n. Let's take some example. Example 1. 2 exponent 3 divided by 2 exponent 4. Alright, so now because they are dividing the quotient law, you have to subtract the exponent. So this is going to be 2 exponent 3 minus 4. Don't go and change the positions. It should be systematic, okay? Yeah, respective. So this one is 2 exponent negative 1. I'll come back. I'll tell you how to write this one, okay? So this is the answer for this question. Then we'll move on. Let's take another example. Let me see if I put some examples here. Okay, so if we have y exponent 5 over y exponent 3, all right? This can be written as this: y exponent 5 minus what? 3. Okay? So the answer is y exponent 2. That is the answer. That's the second law. I hope you are taking note of them. Right, take note of all the things that we're doing. Later, you can go over it. So that's the second law. Very simple. Okay, let's go to the third law. The third law of motion. Third law of indices. Third law. Yeah. Okay. Now, this is the third law. Let's see something. If you have a exponent 3, this. All right. A exponent 3, all exponent 2, or all raised to the power 2. This one can also be rewritten as this: a exponent 3, okay, is that not it, times a exponent 3. Okay, so this one, that is twice of it. It's raised to the power 2, so twice of that. And now, using the first law of indices, this is a, this is a, so we have a exponent 3 plus 3, which is 6. Okay, right. So from this, we can deduce our third law. And the third law goes like this. This is the third law. If you have a exponent m or exponent n, then the answer is a exponent mn. All right? So they're just going to multiply. If you have a number raised to the power whatever, and all raised to the power whatever, what you have to do is to pick that number, then you multiply the exponents. Okay? So to make it clearer, let's take some examples. So we're still with the third law. The third law says that a exponent m, all exponent n, will give you a exponent mn, right? Great. So example 1. So we have 3 exponents. Let's do this: 3 exponent 2, all exponent 3. And that is, according to the law, 3 exponent 2 times 3. That is 3 exponent 6. Hope you agree. So when you see like this, what you have to do is to multiply the exponents. The one on top inside and the one outside. Yeah? Brilliant. That's it. You got to vitalize your body. Vitalization is very, very necessary. Then we'll move on. Let's take another example. Right. x exponent 4, and here 3. Okay, brilliant. Then move on. So if it's something like this, like I said, according to the law, you just multiply them. So we're going to have x 4 times 3, which is x 12. Okay, and that is the third law of indices. That's the third law of indices. Let's move on. We've done 3 solid laws, and yeah, some of the things that we have to take note of. And so things I have to take you through. So I think at this juncture, you're really coming up. Yeah. Now you've graduated from class 1, in indices class. Now you come into class 3. Okay, from grade 1 now you're in grade 3. All right. Yeah. So let's move on. Let's go over some rules. Yes, indices is actually governed by some rules. It's very necessary, very important. You gotta know it. Okay. So let's take a keen look at some of the rules that will help us to solve questions, under indices. Okay, so rule number one. The rule is a not. So if you have a raised to the power 0, the answer is 1. That's the first rule. Okay, right. So a raised to the power 0 is 1. Meaning a number raised to the power 0 is 1. Okay, that's the index, the 0 index. Okay, so this rule 1, we call it the 0 index. 0 index. Okay, so if you have a number raised to the power 0, then it's 1. So example, if I give you 100 raised to the power 0, it's 1. All right. If you have 21 raised to the power 0, the answer is 1. Okay, and that's it. It goes like that. Okay, and this one can be proven. It's a very simple way to prove it. That is 1. If you have any number raised to the power 0, take note that is 1. All right, and we can prove it using a quotient law. The quotient law says that a exponent m divided by a exponent n is equal to a exponent n minus what? N. All right, so let's make a exponent n, this one, let's make it m. So if we make that one m, we're going to have a exponent minus what? M. That's going to give us a exponent 0, which is equal to what? 1. All right, because if you subtract that, okay, you get what? You get 0, and that is everything is 1. Okay, and that's it. Now let's move on to the rule number 2. Rule number 2. That is very simple. Rule number 2. We have this one. If you have AB, all exponent n, this is self-explanatory. Okay, so you have all this exponent n. That is the same as a exponent n, b exponent n. Okay, that's it. That is, so example, if you have 2 times 3, all exponent 2. This is the same as 2 exponent 2 times 3 exponent 2. Okay, so we have 4 times 9, which is 36. All right, that's it. Now we're moving on. Rule number 3. Rule number 3. There's a rule number 3. That's the negative index. Okay, the negative index. Rule number 3. Negative index. And that's the rule number 3. If you have a exponent -n, all right. Yes, if you could recall, when we were talking about the quotient law, I got an answer that's kind of like this: ax in the negative one. I said I'll talk about that. Yeah, so if you were listening to me, you know that I said something like that. So now let me talk about it. This is the third rule, okay? If you have a negative index like this, it's the same as writing 1 over a exponent n. Okay, so that's the reciprocal of that one, but this time around a positive index, not a negative one. Okay, so when you reciprocate it, you rather change the negative to positive, but the same number or the same index. Okay, so therefore, if you have 3 exponents negative 4, this is the same as writing 1 over 3 exponent 4. Okay, or you have 2 exponent negative 5, the same as writing 1 over 2 exponent what? 5. Alright, and you can change that one to a whole number. You can change it from the index form to a whole number. Did you get it? Right, so that's the negative index. Alright, we're going to solve some examples, so don't worry. We'll apply all these rules and laws that we're going through. Let's go to the next one, rule number 4. So take note of the third rule. You'll be needing it, okay? Alright, so we go to rule number 4. Rule number 4. And that is the index of quotients of two numbers, okay? So the index of quotients of two numbers, what I mean by this, a over b all exponent n. Alright, so the index of quotients of two numbers, if you have something like this, that's a fourth rule. It's the same as a exponent n, b exponent what? N. Simple as that. Alright, so the index of quotients of two numbers, take note, if you have a quotient like this of two numbers with an index, then we can write them in a different form like this, okay? And there we go, right? So for example, if you have 3 over 6 all exponent 2, this is the same as 3 exponent 2, 6 exponent 2, and that is 9, 36, 1 over 4. Alright, as simple as that. You get it. Brilliant. Good. Or if you have 2 over 5 all to the power 2, yeah, that is 2 exponent 2 all over 5 exponent 2, and that is 4 over 25, and that's your final answer using rule number 4. Okay, right. You hear me? I see you enjoyed the lesson. Okay, so now let's move on to rule number 5. Rule number 5. Rule number 5. Okay. Rule number 5. Yes, so the negative index of the quotient of two numbers. Negative index. Rule number 5. And I say it is a negative index of the quotient of two numbers. Okay, so if you have a over b exponent negative n. Don't scratch your face. It's not difficult, yeah? Good. Alright, so if the rule 5 says that this can be written as this: b over a all exponents n. That is what the rule 5 says. So you can write this one in that form. Okay. Now I'm not going to be asking the question, how is it like that? How? Okay. You want me to prove that? Alright, so let me prove that. This can be proved. Yeah? Great. Let me clean this one. Let me just clean it. Now, if you want to solve this one using the very rules and the very little knowledge I would know, this one can be written as this: a exponent negative n. This is b exponent negative n, right? Great. Now, using one of the rules, we have this for negative exponents, right? So rule 2, we have 1 over a exponent n divided by 1 over b exponent n. Hope you agree. Okay, so according to the negative index, if you have a exponent negative n, it can be written as 1 over a exponent n, as well as that, right? Good. I'm trying to prove what the rule. Great. So now this one, with the elementary fractions, in elementary school, we did fractions, dividing fractions, multiplying fractions, and all of that. So this one, because they're dividing, if we want to change the sign from division, okay, to multiplication, what you have to do is to turn this one upside down. So that is going to be like this: 1 over a exponent n times b exponent n all over 1. All right, so now we have this: multiply numerators, multiply denominators, any. So that we have here b exponent n. This is a exponent n, right? And that brings us back to what I was talking about, the rule. The rule says if you have a, b, all exponents negative n, it's the same as b over a, all exponent n. And that is what we have here. All right, that is the rule number 5. This one can also be written as this. And there you go. Very simple. So I've proved the rule for you. I've explained why, if you have an index like this, a over b, all exponent and negative index, you just reciprocate it. You change the position of the numerator and the denominator, then you're going to have a positive index for them. Very simple. Do you see? Okay. So let's solve an example. Solve an example regarding this. Yeah? Okay, so let's take this example. 2 over 3. All exponents negative 2. All right, so with this, it's the same as writing, 3 over 2 exponent 2. So I just swap the positions. This will be equal to 3 exponent 2 over 2 exponent 2. So 3 exponent 2 is 9, 2 exponent 2 is 4. 4 over 9 becomes our answer. Isn't that simple? Okay, now let's go to rule number 6. I want me to do another example here, all right? So 5 over 8, all exponents negative 3, all right? All exponent negative 3. Let's move on. So now what we're going to do is to make it 8 exponent 5 all over 3. All right, so now this is going to give us 8 exponent 3, 5 exponent 3. Now 8 exponent 3 is 5, 1, 2. Then 5 exponent 3 is 1, 2, 5. So that brings us to the final answer. You can reduce that one if it's possible. That's it, yeah? Great. Rule number 6. Rule number 6. So we're going to rule number 6. Rule number 6. Now rule number 6 is very simple, okay? If you have something like this, a exponent 1 over 2 is the same as square root of a, okay? So therefore, if you have 2 exponent half, the answer is square root of what? 2. All right? And if you have a exponent 1 over 3, that is cube roots of a. Okay, a exponent 1 over 4 is the fourth root of a. A exponent 1 over 5 is the fifth root of a. Okay, so in the same vein, the reverse is also acceptable. If you're given this, all right, you can just write it as this. Sorry, over 9. Okay, and if you're given maybe 4, so cube root of 4, you can just make it like this: 4 exponents 1 over 3. It's also correct. So that's a rule number 6. All right. So we've done a lot of things. Okay, we've done a lot of laws, a lot of rules, and the next thing we have to do is to solve some examples. So now we're going to solve multiple examples under this. You got it. Get ready. Get the things that you need, your paper and pen, and all that you need for us to solve some examples. So when I put the question on the screen, you're just going to have a look at it. All right, then you solve it. You can pause the video and you solve it. Later you come and check how I've solved it and you compare your answer. All right, or you can just follow me, then we'll solve it together. Okay, right, let's take some examples and solve. I'm going to solve some examples, like I said. Okay, let's take the first question. We're to simplify 16. So number 1, we're to simplify this: 16 over 81, all raised to the power -3 over 4. So this is our first question. We're to simplify this. Take a look at it. I don't think it's difficult. It's not difficult, right? Good. So can you try it? Okay. Yeah, so try hand on. I'm giving you 1 minute. Come on, that's too much. 1 second. Okay, 1 second. All right, then let's do it. Let's do it together. Okay. This one, we went through the rules. Okay, and we learned that when you have something like this, because the negative, if you want to eliminate that negative, what you have to do is to reciprocate this fraction. Okay, or you turn it upside down. Okay, bring the denominator up and take the numerator down, so that this one will change to positive. Okay, right, that was rule number 5. Great. Now let's do that. So this is going to be like this: 81 over 16, and our friend becomes 3 exponent 4. Yeah, the next thing is we can expand this one. Okay, so let me write it so that you won't get confused. This 81 3 over 4, okay, and this is 16, also 3 over 4. Is that not it? We are there, right? Good. So now what we have to do is to write this 81 in an index form. Okay, we can write 81 in an index form, as well as 16 too can also be written in an index form. Okay, now 81 is 3 exponent 4, so 3 multiplied by itself 4 times will give us 81. So now instead of using 81, we're going to use 3 exponent 4 so that it will match up with the exponent there. So we continue. We have 3 exponent 4 times the exponent is 3 over 4, okay, over 16, which is 2 exponent 4. So 2 exponent 4 times 3 exponent 4. Now you'll be wondering why I'm using, exponent 4, exponent 4. The reason I'm doing that is I wanted to match it with this so that I can cancel it. Okay, with a 16, I can even use 4 exponent 2. Okay, but then I don't want it that way because I want something that can cancel out the 4. All right, that's the reason why I use 2 instead. And here too, I made it 3 exponent 4. Yeah, so that the 4 can cancel out. So now let's do that. This 4 cancels this 4 cancels that. Now we are left with 3 exponent 3 over 2 exponent 3. Okay, and this can also be written as 3 exponent 3 is 27. then 2 exponent 3 is 8. So this is our final answer. Very simple and so clean. Okay, so from here we came to this place, we came to this place, now we got here, now we've arrived at our answer. All right, is that not simple? Okay, since you're saying it's simple, then let's do another example. I mean, just for fun. Yeah, good. All right, example number 2. So number 2, let's our example. 64 over 25 over 2. So 64, 25, all exponents half, right? Good. Now let's go. What we have here, you know what to do, okay? Because of the negative here, what we have to do, reciprocate the fraction. So we're going to have 25 over 64, right? Over 2. And this is the same as 25 exponents half all over 64 exponents half. You agree? Great. Now, the denominator here for the exponent is 2. So we need a number that we can write it in this form, okay, with exponent 2 so that it can cancel that one out. So with 25, I think we can use 5. 5 exponent 2 is 25. So that 2 can cancel out that. What about 64? 64, if we use 2, it's exponent 6. So exponent 6, and we don't need 6. We want 2. And 4 2 won't give us that. So I think we can use 8. So 8 for that. Now since we know, we'll move forward. 25 is 5 exponent 2 times the exponent that's already there. 64 is 8 exponent 2 times a half. And that will give us, so this cancels that, this cancels that. 5 over 8. This is even simpler than the first one. That's it. That's the answer for this one. 5 over 8. Okay? Is that not simple? It is, right? Good. So, we are done with that. Let's do another example. For this one, you're going to do it. Come on. I've been doing all the examples for you. You do this one. So, example number 3. Example number 3 is 8 over 27. Yeah, so do that one for me. I'm going to close my eyes. So when you do it, you tell me the answer. Close my eyes. What is it? What'd you get? Oh! Okay. So you do that one for me. This is for you to do. For you to do. So you want me to assist you? I know. Okay, so this is going to be, we turn it upside down. We have 27 over 8. And that is 2 over 3. Okay, so this one is going to be, yes, so 27, 2 over 3. This is 8, 2 over 3, right? Good. Now that can be written in an index form. I mean 27 with exponent 3. What's that? 3 exponent 3, right? So 3 exponent 3 times 2 exponent 3 over 2 exponent 3 times 2 exponent 3. 3 cancels that, 3 cancels that. We're left with 3 exponent 2 and 2 exponent 2. 3 exponent 2 is 9, 2 exponent 2 is 4. And that is our answer for that question. Okay? Right. So now, whenever you encounter a question like this, I know it's going to be super easy for you because we've done some examples under that. Okay? Right. Let's graduate to a different dimension. We solve examples. Yeah. We graduate into a different dimension. Let's see. We have some examples here. Let's see. Okay, so now this is 27 exponent 2 over 3 times 64 exponent 1 over 3 divided by 81 exponent 1 over 4. It looks quite long, huh? No, but it's not difficult. Okay, sorry. Okay, so now here we go. We have to simplify this. If Shaggy said this, if you say come on, it's difficult. No, this is not difficult. So what you have to do first is to write these big numbers in index form. Okay, we can write these ones in index form, right? So 27 becomes, now when you're doing it, you have to be checking the exponents, okay? I mean the denominator of the exponent, so that you can write it in a way that it can match and you can cancel. So here we have 3 exponents 3. That one goes with 2 and 3. 64, we have 4 exponent 3. So 4 exponent 3 times, okay? Then we have this one is 4. What are we using? The 3 exponent 4. So 3 exponent 4. 3 exponent 4 times 1 over 4. Okay, right. So you see that I had to make sure that I write it in a way that it will match with the denominator so that I can cancel out, like I was saying. You don't just write it, okay? So now, what we have to do, we know that we can cancel these ones. We can cancel these ones, okay? Now here we're left with 3 exponent 2. Here we're left with 4 exponent 1. There's no need to put it there actually. Then we have 3 also exponent 1. These ones are not necessary, so let's claim them. Okay, now with the first law of indices, the multiplication law, because they have the same base, let me write it like this: 3 exponent 2 times 3, this is exponent 1. Sorry, that's supposed to be divided times the 4. Okay, so I pick this one divided by the 3, then times the 4. I can do this one. Now wait till, that's the second law, okay? 2 minus what? 1. So that's going to give us 3 exponent 1 times 4 exponent 1. So the answer is 12. Was I Russian? Oh no, I wasn't. You know I wasn't. Okay, so this one is the same as 3 exponent 2 minus 1, okay, times 4. And that is what I did here. 2 minus 1 is 1. Okay, so 3 exponent 1 is still 3, and 4, 12. Right? Is it not simple? It is, right? Okay, let's move on. Solve another example. I want to look for another example for you. Okay. Let's see. Let's try this one. We're going to try this. We're going to try this. We're going to try this. Very long question I have here. Okay. So 16 over 81 all raised to the power negative 1 over 4. Then multiplying. This is 32 over 243. 1 over 5, another 1, 4 over 9, 1 over 2, another 1, that's 3 over 2, 3 over 2 raised to the power 0. So this is a very long question, and I mean we have it here, very long question. So try a hand on that. Yes, you're going to do this one. So solve this one. Let me see what you're going to get. This is for you to do. Okay, this is yours. So do that one. What you have to do, you see that this one, we have to reciprocate it. Okay, so that is going to be 81 over 16 we have 1 over 4. Now here, there's nothing that you're going to do. So we're going to have, let me repeat it, 32 over 243, 1 over 5. This is also the same, 4 over 9, 1 over 2. This whole thing will give us 1 actually. This whole thing will give us 1 because its exponent what? 0. Alright? So now we have to take our time and write this one. This is 4. So we need 3 exponent 4, 2 exponent 4. Then we come to this place. 32 will give us 2 exponent 5. And this is 3 exponent 5. We're moving on. So let's do it. Here is 3 exponent 4. Okay? Times 1 over 4. Here is 2 exponent 4 times 1 over 4. Then in a bracket, we come to this place is 2 exponent 5 times 1 over 5. And this is 3 exponent 5 times 1 over 5. This is 2 exponent 2 times 1 over 2. This is 3 exponent 2 times 1 over 2. This whole thing is 1. Okay? So let me clean this to make out. Okay. So I'm bringing this one here. I cancel this and that. I cancel this and that. I'll be left with 3 over 2. Then I cancel this and that. I cancel this and that. I'll be left with here will be 2 over 3. I cancel this and that. This and that. I'll be left with another 2 over 3. And here will be 1. So you multiply these ones. Some of them will just cancel, right? So multiplying these ones. This one cancels that. This one cancels that. The answer is 2 over 3. That's the answer. Isn't it all simple? It is, right? So this one cancel, and then you are just good to go, right? Okay. Then let's take another example. So this one, in fact, I'm not even going to touch it. Do this one for me. This is for you to do. 49. So this is try. 49 exponent 2 over 3 divided by 49 exponent 1 over 6 all over 1 over 7 exponent 7 over 6 times 1 over 7 1 over 6. So this is for you. It's for you. It's not for me. Okay? That is your work. So do that one for me. For me. Yeah? Great. Now, when you're done with that, you can leave the answer in the comment section. Alright? And I'll check it for you. Okay? Brilliant. The answer for this is 1. Just 1. So do that. You should get it. Great. Now we're going to... I'm cleaning the question. All right. Let's talk about exponential equations. Equations involving indices. That's what we're going to talk about. Equations involving indices. Right. That's what we're talking about. Equation involving indices. Let's take a first example. We have 3 exponents x plus 1, okay, equal to 3 exponents 9 exponent 4. All right, that's what we have. Let's do that. If you have a question like this, you have to find the value of x. Find the value of x. So to find the value of x, this is what you're going to do. Let's repeat this one. 3 exponents x plus 1 Now 9 can be written in an index form. Make sure that they have the same base, okay, both sides. So here will be 3 exponent 2 times 4. All right, this is 3 exponent x plus 1 equal to 3, 2, 4 is 8. Now, this is a rule for the exponent. If they have the same numbers at both sides, okay, the same number, so here is 3, here is 3, what you have to do is to pick the exponent and equate them. Okay, so here we'll pick the exponent x plus 1 equal to 8. You see, so now we have x equals 8. Now we bring that 1 to the other side, subtract. So that is x is equal to what? X is equal to 7. Hope you agree. Brilliant. So that's the answer for that. Let's take another example. Example number 2. 64 exponent x equals 16. So with this, we have to write the 64 in an index form. Okay. Yeah, let's change that one. Okay, I think we can use 4. Okay, so we can use 4 exponent 3. All right, 4 exponent 3. So that one. And here we can use 4 exponent 2. So we can just equate now because they have the same base. All right, so the numbers here are the same. We just equate the exponents. So we're going to have 3x equals 2. Because we want the x, what do we do? Divide here by that, divide here by that. X is 2 over 3. As simple as that. I hope you are getting it. Okay, let's do another example. So see this. Example 3. 8x minus 2 equal to 2x minus 8. Do you see? All right, so now we have something like this. Okay, this is bigger than this, so we can reduce this one to 2. Okay, so that is 2 exponent 3. 2. Do you agree? Okay, so you see, I wrote this one, I changed it to index form. That is 2 exponent 3, the same as 8. Now, because they have the same base, we just have to equate the exponent. So we'll pick this one equals that. That is 3x minus 6 equals. Please, I hope you know why it's that, because this one multiplies that, okay? This one. Yeah, so now we can group like terms. This one comes here. So 3x minus x equals minus 8. This one is plus 6. All right? Yeah. Now, this is 2x equals minus 2. So now 2, here 2. So x is equal to negative 1. So we need to find the value of x. Anytime you have a question like this, find the value of this, find the value of that. If it's equations, then you're going to use this method. Okay, guys, I have taken you through virtually everything you need to know. And indices, we've done a whole lot of things today in this lesson. Okay, I think I'll just do the last example with you. So let's do the fourth example. 2x minus 1 equal to 1 over 16. We have to find the value of x. It's not difficult, guys. It's not. So what you have to do, okay, let's repeat this one. 2x minus 1. This one can be written as this, 16. Okay, you remember. Right, so the rule number 2. We just have to flip it back. Negative index. This 1 over 16 can be written as this. So it was like this, and we brought it to this place. Okay, now here is 4, here is 16. To be able to equate the exponent, we have to do something to this one. It has to be 4, okay, so that we can do that. So let's do something to the 16. All right, so like I'm saying, this one, the 16 can be written and in an index form so that it will match with this, the 4. Okay, because here is 4, we have to write this one in index form using 4. That is going to give us, this is 4 2x minus 1 equal to, this is 4 2 minus 1. All right, we are almost done. So now we'll pick the exponents. That is 2x minus 1 equal to 2 times minus 1 is minus 2. So we have 2x equals minus 2 plus 1. Okay, now here we will be having 2x equals minus 1. So now here 2, here 2, this one cancels that. S is equal to minus 1 over 2. And that's it. It's very simple. You see, very, very simple, guys. So now we've come to the end of our long lesson. All right, we've come to the end of it. And I'm just going to leave you with some questions to do. I hope you've enjoyed the lesson. You have really enjoyed. Let's take these questions. And I know it's really going to help us. So take this 1 or 2 questions. You have to find the value of x. Find the value of x in each case. All right, 1 2 exponent x. Okay, 8. Then another one, number 2 is 3 exponent x plus 1 equal to 81. Then number 3, we have 3 exponent x equal to 1 over 27. Number 4, we have 2 exponent x equal to 1 over 28. Then number 5, 5 exponent x 1 over 25, 125. Okay. Then number 6, 10 exponent x plus 2 equal to 100. So these are the questions I'm giving you for you to do for me. Okay, very simple, questions, and you ought to try that for me. Okay, now there are some aspects that I've left out. The simultaneous equation. You can use indices, okay, to do simultaneous equation, and you can also get quadratic equation out of it. And these are the 2 aspects I've not touched. So I'll do that in the next lesson. Okay, I'll talk about that. Now, I know you've enjoyed the lesson. There are a lot of lessons like this that I'm going to be releasing. I'm going to make it comprehensive. I'll pick a topic and I'll take you through all the things that you need to know. And I'll be talking about some past questions too, so that it will help you. If you're preparing for any exams and all that, just let me know. If there's any topic that you want me to take you guys through to, just let me know. And I will do that, okay? So with this one, that's what you're going to do. This 8, you just have to write it in an index form. When you write this 8 in an index form, then it will match up with this. You pick the exponent and you equate them. So this is 2 exponent to what? 3. So x is 3. We come to this one. The 81 can be written in an index form, okay? So 3 exponent 4 will get you that. Then you pick the exponents. For this one to the 1 over 27, you just have to write a 27 like this, okay? Then you write that in an index form and you pick it. The same for this. The same for all of them, okay? Brilliant. I think you don't have any issue. We've gone through the laws, we've gone through the rules, all right? So a quick revision, a quick summary. We did the law 1. That is a multiplication law, and we deduced that if you have a exponent m times a exponent n, then you add the exponents. and we came to the law 2 that talks about the quotient. Okay, the quotient law. So if you have a exponent m divided by a exponent n, that is going to give you a exponent m minus n. Then we came to the third law, that is the multiplication of the exponents. Okay, so if you have a exponent m or exponents n, then you just multiply the m and the n. Do you see? Very simple. Then we went through some of the rules. And one thing that I didn't talk about, if you have any number exponent 1 is a number itself. So a exponent 1 is 1. 2 exponent 1 is 2. Okay? And we said any number exponent 0 is also 1. Alright? Then we went through the negative index. That is 2 exponents. Negative 1 is 1 over 2. Or 2 exponent negative n is 1 over 2 exponents what? N. We went through that of the quotient, the quotient, okay? And we said we have a over b all exponent n is the same as a exponent n, b exponent n. We've done a lot in this lesson, and I know you've enjoyed it. Thank you so much for watching, and keep supporting. Bye.